Well, good afternoon, ladies and gentlemen. I hope you're all enjoying it. I'd like to start just thank, I said this yesterday, Project Fire, I think you've done an absolute wonderful job setting this up. It's been excellent. So thanks for giving us the opportunity to talk. Quick introduction, like Andy said, I'm Sam Grigg. I work for SPP Pumps. Some of you may be aware of SPP. SPP is a pump supplier. Hold on, let's get this going. Pump supplier. We specialise in fire protection pump packages. SPP has been going now for 130 years now. Some people older in the industry might have known us as Sigmund pulse meter pumps. So that may bring a smile to a few of you. But today I'm going to talk about, it's really a concept. I didn't want to come up here and do a sales pitch on pumps or anything like that. So it's just an idea on high-rise fire protection. It seems to be the hot topic at the moment. Everyone's talking about big residential properties, big high-rise properties and things like that. So I'm sure you're all aware the population seems to be increasing, especially in where we are today, London. London is getting busier and busier and busier. And this is where we're starting to encounter these real high-rise properties and super high-rise and things like that. So, but due to the height of these properties, we start to encounter more and more challenges with fire protection. So let's have a look at this. Population. So why is there this increase in high-rise buildings? So let's take London for an example. London now has a population, and it grew twice the rate of the rest of the UK since 2011, 2017, twice the rate. We now have 8.8 million people living in London, 8.8. Set to hit 10 million people by the year 2025, all in an area of 1.5 kilometres squared. So there's a lot of people. It's a lot of people. So this increase in population requires housing. This is, I don't know if people are aware, this is Canary Wharf from East London now. This has got, it's back. This has got some of the biggest residential towers going in London at the moment. Some of these are going up to 200 metres high. So with high-rise residential towers are now regarded as the biggest players in the property market, the biggest players. The average cost of premium residential land in London is in the millions, so it makes sense for investors. They're starting to build up instead of out. They're all building higher and higher and higher. So we've had an increase in the number of high-rises over 100 metres. Now, these are statistics here. The UK development pipeline currently stands at 500 new builds at over 100 metres. So it's 500 been approved, over 100 metres. 85% of that 500 is here in London. The rest is scattered around a few major cities in the UK. So 85% of that. Of that 500, 70% of it is residential. 70% is residential. So it's a big chunk of it. We can see that here. If you have a look at this graph, it sort of represents it. So what you can see, it's 3% for hotels, you can say it's 19% for mixed use. That could be partly residential as well. 3% for other, 5% for office, and the big chunk of the pie, 70% of residential. So you can see where all the investment's going. But the appeal's there for the investors as well, with a high selling cost as premium land and the need for more housing. So just to give you an idea, a two-bedroom apartment in central London now has an average cost of £1.2 million, two-bedroom place. So they all want to sell them. So fire protection is essential. It always is essential. So in the UK, we talked about it earlier, we have a British standard, 92514, domestic and residential occupancies. And these are the codes we have to adhere to. Okay, as it stands in the UK, there's no requirement under this code to have listed products. We don't need listed products. So we can put pretty much what we like in there. So, but why do we need listed products? And what's the difference between listed and non-listed? Well, just to give you a quick example, our listed fire pump, compare a listed fire pump to an industrial fire pump, industrial pump, sorry. Our listed pump have upgraded materials, they have larger shafts, we put double bearings on them, we do different hydraulics, different curve shapes. Now we need this. If you think of a fire pump, it stands idle for most of its life, and then we need it to get to duty point as soon as possible. So there's a big difference between a standard industrial pump to a fire pump, a complete difference, and this is why we like listed products. But let's have a look at the standards we look at. Now, if we compare commercial to residential, commercial installation, if we call high-rise, it's funny, we spoke about it yesterday, in the pump world, we call high-rise anything over 45 metres, we call a high-rise. Now, the guy from the fire brigade was talking about, was it 4 floors or something like that, 30 metres, but we've always said 45 metres to us is high-rise. So Let's have a look at these standards. So let's compare the two. The Code of Practice for commercial type properties adhered to EN 12845. I'm sure we're all aware of that. Under these standards, high-rise installations over 45 metres must be subdivided. They must be subdivided into sprinkler installations. FM as well. FM have got the same fault patterns. FM, instead of 45 metres, they'll use 84 metres, 275 feet. Well, it is a quick look at EN 12845, and we can see here, this is an extract, and this is Annex E, and you can see this is a 90-metre installation there, 90 metres, but because it's over 45 metres, it's been put into two 45-metre zones. You've got a set of pumps for the lower zone and a set of pumps for the higher zone. Now, the fault patterns behind this is we're trying not to over-pressurise each zone. So we come out of the pump, we've got a riser coming up, and we've got nothing in the way, so we don't want to put too much pressure in the lower zone for the pressure we need in the higher zone. This is an extract for FM as well. FM have got the same fault patterns, different height, but the same sort of fault patterns there. They're looking at 84 metres, 275 feet, but again, that's a single zone pump system there. Anything over that, you need to put it into zones. So it's interesting to see. So what do we do in the case of residentials, especially in high-rise? Should we have the same fault patterns? And what is being installed? Well, as it stands, there's no hard and fast rules for subdivisions in residential installations, none at all. The system could be fed from a high-pressure pump, and it had enough pressure to get to the highest sprinkler head or the most remote area just to give it that sort of pressure, which is fine for the higher floors. We can remove the static pressure as we go up the building. But what about the lower floors? It may be that we've got so high pressure there that the components can't handle it. So what do we do? Well, this is where we see the use of pressure reducing valves on these systems. Well, pressure reducing valves themselves, they carry issues as well. And some parts of the world, their use has been completely banned. You can't use them in fire installations. Pressure reducing valves are prone to sticking open or closed in fire systems. These PRVs work fine in different applications, but for some reason in fire systems they seem to fail and we seem to have a lot of issues with them. But why is that? But some of the reason behind it, I've just got some photos of some old valves there, but the big difference between fire applications and other applications is other applications are constant movement of fluid, if you like, process or things like that. There's constant fluid or water's moving through them, they're operating all the time. But fire systems are sitting idle for a long, long time, doing nothing until they're called for, until there's a system demand, a header operating or a hydrant open. So sitting idle for a long time, they fill up with rust, corrosion, they reduce the movement in them. This can cause a situation where we've reduced or increased pressure, which to a fire system is a nightmare. There's one that's just quickly, I'm going to flip, some people may be aware of this, is back in 1991 in Philadelphia. At the time was a huge incident in America. The reason I bring this up is because it's, well, you'll find out at the end, but it attributes to pressure reducing valves. Now, they really struggle. This is One Meridian Plaza in America there. Now, this actually caused the death of 3 firefighters and 24 serious injuries. Now, this burnt for 19 hours, this fire, and they really struggled to control it. The main reasons they struggled to control it is they lost the electrical systems for the building, but the other reason was their poor water pressure by improperly set pressure reducing valves. They couldn't fight the fire because the standpipes didn't have the pressure they need, and we actually lost lives over it. So do we need to change the way we look at residential protection? I believe that we need to at least consider the options. Can we afford a faulty component not to operate when we need it and cause a disaster? Okay, pumps are critical to any sprinkler system, and the simplest route from the pump discharge to the sprinkler head will always be the best. It will always be the best. So, I'll keep running my time. So what options do we have? Well, we do have options. Can we take the ideas of EN 12845 or FM? Do we need to subdivide at a certain height? So we don't over-pressurise systems and we don't have to use pressure-reducing valves, so we can reduce that risk. We can use multiple pumps in separate, to supply separate riser seat zones, so we could have a set of low-rise pumps, a set of high-rise pumps. Can we install pumps at various heights in the building? We could do that. We could do that, but we've got to think about water supplies, getting them up the building. Multi-stage, multi-outlet. We do this for EN LPC approved projects as well, so we do that for high-rise projects. We could have a pump with multi-outlet stuck in the basement serving different areas of it. Do we need approved products? I think this is a big one for me. Do we need approved pumps in residential? We look at it as something else, but do we need approved pumps going in there? These are all things we need to consider. So, and that's it for me. It's quite a quick presentation. Thanks for staying with me. So, my questions there, should high-rise residential installations be subdivided, put into zones? So, thanks guys. Thanks for your time. Thank you very much.